Your phone fires 30,000 invisible dots to build a three-dimensional map of your face. It happens in a fraction of a second in total darkness. And it's exactly why a printed photo can't fool it. You do this hundreds of times a day. Each glance opens your photos, your messages, your bank, your payments. A tapped code or a fingerprint is flat. It can be watched over your shoulder or lifted off a glass. So your face has one hard job. Prove it's a real, living, three-dimensional face. Get that wrong and a stranger walks in, or you get locked out of your own phone. Start with where the dots come from. Inside the top of your phone sits a tiny laser. It fires a single beam into a small glass filter etched with a precise pattern. That filter splits the one beam into roughly 30,000 separate points, sprayed out in a fixed grid. Think of one flashlight passing through a stencil and coming out as thousands of exact pinpricks of light. Here's the clever part. Those dots are near infrared, a color just past red that your eyes cannot see. The wavelength is about 940 nanometers, invisible to you but glaringly bright to the phone's infrared camera. So the whole light show happens right on your face and you never notice a thing. This trick has a name: structured light. Instead of guessing at your face, the phone throws a pattern it already knows onto you and watches what happens to it. The dots are not random. They land in a shape the phone has memorized down to the pixel, which sets up the real question. Projecting a known grid is easy, but a grid of dots is still flat information. How does a spray of glowing points turn into actual depth, into the difference between your nose and your ears? That covers how the dots get out. Now the phone has to read them back. The infrared camera, sitting right next to the projector, takes a photo of exactly where all 30,000 dots landed. And here's the key. The dots don't stay in their neat grid. On a surface that's close to the phone, the tip of your nose, the dots shift and crowd together one way. On a surface that's farther back, your cheeks, your ears, the sides of your jaw, those same dots spread out and sit differently. The pattern the phone fired was perfectly regular. The pattern it gets back is warped. And that warping is not noise. It is the information. Because the phone knows the exact grid it sent, it can measure how far every single dot moved from where it should have been. A dot that jumped a lot is on something close. A dot that barely moved is on something far. Do that math across all 30,000 points at once, and you get a depth map. A picture where brightness means distance, not color. From that depth map, the software builds a three-dimensional mesh. A fine web of tiny triangles that traces the exact hills and valleys of your face. Your brow, your nose bridge, your chin. A flat photo could never produce this warp. But a screen playing a video might. So how does the phone make sure it's looking at you and not a clever picture? Here's where it gets clever about faking. First, the darky. There's a second light source called a flood illuminator, and it washes your whole face in even infrared light, the light you can't see. That's why face unlock works in a pitch-black room. The phone brings its own invisible lighting. Now defeating a fake. A printed photo is flat. It has no real geometry, so when the dots hit it, they don't warp the way a real nose and real cheeks do. The depth map comes back nearly flat and the phone rejects it. To beat a video on a screen, the system can also demand attention. Your eyes open, actually pointed at the phone. No stare, no unlock. That's a liveness check. Proof there's a living person behind the glass, not a picture. Then comes the part that matters most for your privacy. The phone does not save a photo of your face. It turns that three-dimensional mesh into a long string of numbers, a mathematical description of your geometry. And it locks that string inside a walled-off chip called a secure enclave, encrypted right there on the device. It never rides to a server. It never sits in the cloud. So even the company that made the phone can't pull your face off a database somewhere. But numbers in a vault only help if the matching is fast. So how does all of this happen in the blink you don't even notice? So watch the whole thing run at full speed. You lift the phone. The projector sprays 30,000 dots. The infrared camera reads how that grid got warped by the shape of you. The software turns the warp into a depth map, then a three-dimensional mesh. It compares that mesh against the encrypted string of numbers already locked in the secure enclave. Match and you're in. All of that start to finish in a fraction of a second. And here's the elegant part. Because it's matching three-dimensional geometry and not one frozen snapshot, it can quietly keep up with you. New glasses, a fresh beard, makeup, a different room's light. The underlying shape of your face is still the same shape. So the phone updates its own model as you drift, instead of locking you out. That's the promise paid off. 30,000 fleeting dots become one encrypted three-dimensional map, and that map only springs open for the living, three-dimensional face it was built from. Not a photo, not a video, you. So next time your phone unlocks itself in a dark room, picture it. 30,000 invisible dots landing on your face, a map building in silence. The world is full of quiet machines like this, working in the light you can't see. Stick around and we'll keep opening the box on the tech you use without a second thought.